Hi guys, as promised, this video comes by requirement, and we're going live here for grade 10 mathematics, and the chapter we're basically looking at is quadratic equations and their applications. So basically now, if I were to solve something like, let's say for example, if I pick a quadratic equation, and let's say I have something like this: 3y plus 1 into 2y minus 7 is equal to 0. Now already we have two factors here. So that means there's no need for us to factorize this because it is in the factorized form. So what we have is then 3y plus 1 is equal to 0, and also 2y minus 7 is equal to 0. So therefore I got 3y, so we've got two linear equations now from the quadratic equation is equal to the plus 1 can go on the other side, becomes minus 1. So I'm left with y is equal to minus 1 divided by 3. And so I get my first value of y. And I also have 2y is equal to 7. So that means y is equal to 7 divided by 2. And that's my second value for this quadratic equation. So basically, because we have two roots, and here we are, we've already solved this. Now, let's say, for instance, if I take something like this, 4z squared minus 3z is equal to 0. So I would assume that basically you have an understanding of quadratic equations from grade 9. So that's why I'm taking it from there. I'm not going into the basics of explaining how quadratic equations should be solved. But again, we're just picking up questions from the book, and we're solving them straight away based on the knowledge that you already have for quadratic equation. So in this particular question now we've got z and z common, so z can go outside, and inside I'm left with 4z, because 4z times z is 4z squared, minus 3, and 3 times z is 3z is equal to 0. So now we've got two factors again. So here I've got z is equal to 0, and also I have 4z minus 3. 4z minus 3 is equal to 0, which means that 4z is equal to 3 if the 3 can be set over onto the other side. And now I'm left with 3, and the 4 can be set over and gets divided there. So here we are, that's the second value, and this is our first value. So now these are the two values for our equations, and here we are. Okay, next, let me just pick another example. Another questions from the book. And suppose now we've got to solve, let's say, y squared plus y minus 6 is equal to 0. So if I were to solve this, it's not very difficult. So what we basically do, we just create, we put two brackets there. So we're gonna try and look for two factors. And here we'll look at the product and the sum of this equation. This number minus 6 here, if I take minus 6, so minus, let's say, 3 times 2, that's going to give minus 6. But if we look at the sum is minus 3 plus 2, which is then minus 1, and that's not good because here the sum is 1. So what we can do, we can reverse this and say 3 times minus 2. So the product is minus 6, and the sum turns out to be 3 plus the minus 2, and that becomes 1, which is okay because here we've got 1. So this seems to work out, 3 and minus 2. So I've got x, I would rather say y, okay, sorry about that, y minus 2, and then y plus 3. So then y minus 2 is equal to 0, and y plus 3 is equal to 0. So y is equal to 0 plus 2, and y is equal to 0 minus 3. So here are the two values of y, and our quadratic equation has been solved. I don't think that's very difficult, okay, in terms of what we're doing right now. And talking about quadratic equations, I can come up with a very typical example question from the book set by the Cambridge examiners. All right, so we have something from this book here. Okay, just torn a page out of the book, and there's plenty of questions that can be solved. but I'm particularly looking for that question here. The rectangle ABCD, all right, is with AB is equal to x plus 3 and BC is equal to 3x minus 1. Different values of x are involved in each parts of A, B, and C of the question. If the perimeter of the rectangle is 52, form an equation in x and solve it. Now, the perimeter means the sum of all the sides here. That's going to be 52. So what we have is then, this is our rectangle. The first case scenario, this question number 19 from the book, we told that the perimeter is 52. And we've got the sides as 3x minus 1, plus the other one parallel to it is 3x minus 1 again. All right. And I've got plus the other two sides, x plus 3, x plus 3. So x plus 3, and then plus x plus 3. And all of that should be equal to 52 because that's the perimeter. That's the total, the sum of all the sides together. So 3x plus 3x plus x plus x, which is then 6x plus 2x is 8x. I've got minus 1, which is minus 2. 3 and 3 is 6. So minus 2 plus 6. And I've got then 52. So my equation is looking like this. 8x plus 4 is equal to 52. So we can solve this linear equation. And if we were to do this, so x is going to be equal to 52 minus the 4. And the 8 can get divided on the other side. So if we were to do this, and we're going to get something like, so we are allowed to use the calculator because that's paper 2. And so 52 minus 4, and all of that divided by 8, and you get 6. So this answer here is 6, basically. In our first case scenario, when the perimeter was 52. Let's go on to see what they want us with part B of the question. Now, if instead the length of the diagonal AC is 20 centimeters, so we're looking at AC here as 20 centimeters, form an equation in X and solve it, hence find the length of AB. So we're going to have to solve an equation if AC is 20 centimeters. So basically we have got x plus 3, 3x minus 1, and then AC is 20. So if I were to draw a small triangle here, like this, just to keep track of what we're doing. So we've got, this is 20, and I've got, this is x plus 3, and here I've got 3x minus 1. So it's very clear that we are looking at using Pythagoras theorem. So we can use Pythagoras theorem. And if we do this, Pythagoras theorem, so we're going to get 20 to the square is equal to 3x minus 1 to the square plus x plus 3 to the square. So let's go ahead and try and solve this by expanding each of these factors. So we got then, if I were to expand this, I'm going to get 9x squared minus 2 times the whole lot is minus 6x plus 1 then. And over here, I'm going to get x squared plus 2 times the whole lot is 6 again. So plus 6x and then plus 9. And then to 20 becomes 400 because that's being squared. 9x squared plus x squared is 10x squared. Minus 6x plus 6x, so that's going to cancel out. I've got 1 plus 9 is 10. So plus 10. And then I've got 400. Now, both sides can be divided by 10, so I'm left with x squared plus 1 is equal to 40. And if we're to simplify this, I'm going to get x squared is equal to 40 minus 1. So x is going to equal to square root of 39. So basically now I've got the value of x, that turns out to be the square root of 39, which is 6.244997998. So let's say approximately 6.24 centimeters. Now they're asking me to find the length of AB. Now we know that this is AB. All right, and here we've got C. So AB is x plus 3. So what we're saying is that the length of AB turns out to be x, which is 6.24, plus the 3, and so that's going to come to AB is equal to 9.24, right, centimeters. Here we are. That's the answer to the second part of the question. That's part B of the question. Moving on to part C of the question. So let's try and read this. PQRS is another rectangle with PQ is equal to x centimeters and QR is equal to x plus 6 centimeters. The rectangle ABCD now has an area which is twice the area of PQRS. Okay, we understand this. Form an equation in x and show that it reduces to x squared minus 4x minus 3 is equal to 0. Now that's our first part from part C. So what we're going to do is, let me just try and illustrate this by drawing a diagram. Makes it a lot easier for us. Now if I were to, just bear with me. Right. So I've got basically the rectangle they have given to me. That's the original rectangle. And this is the rectangle ABCD. And I have x plus 3 here. Okay. And I also get 3x minus 1. Okay. And then there's another rectangle. And this one they're saying is PQRS. So this is the rectangle PQRS, where PQ is equal to x, so PQRS, and this is x. And further saying that QR is equal to x plus 6. So we've got x plus 6 here for QR. So let us see now. The rectangle ABCD now has an area which is twice the area of PQRS. So area of rectangle ABCD, okay, is equal to twice the area of rectangle PQRS. Okay, so how are we going to try and do this? So that ABCD there, the area here, which is x plus 3 times 3x minus 1, and so x plus 3 times 3x minus 1 is equal to 2 times the area of this one, which is then 2 times x into x plus 6, because again, this is length times breadth, and which is x plus 6 times x, and of course multiply by 2, you're going to get ABCD. So let us see now. We're going to try to simplify this. So 3x times x is 3x squared. And then x times minus 1 is minus x. 3x times 3 is 9x. 9x minus x is 8x. So we've got 8x. And 3 times minus 1 is negative 3. And from this side here, we're going to get 2x times x, which is 2x squared. 2x times 6 is plus 12x. So we can try and simplify this by saying 3x squared minus the 2x squared plus the 8x, and of course minus 12x on this side. And then the minus 3 remains there, and over here we got nothing left, and that's going to be equal to 0. So then I've got x squared plus 8x minus 12x is minus 4x, and then minus 3 is equal to 0. Now they wanted us to show that the equation will reduce to x squared, here we are, minus 4x minus 3. And I think that's what we've got, x squared minus 4x minus 3. And so that has been proved, and here we are. Okay, and let us see. Right. So now we're trying to solve this equation in x, giving your answers corrected to decimal places. If I were to solve this equation to give my answers corrected to decimal places, that means I'm going to be using either formula or I can use completing the squares. All right, so if you use the formula, you can use the quadratic formula, that is x is equal to minus b plus or minus the square root of b squared minus 4ac, and all of that being divided by 2a. And now So I'm going to say x is equal to minus b, and so we know that the value of a here is 1, the value of b is minus 4, and the value of c is minus